Resonance. It is found that all the observed properties of certain compounds cannot be explained by a single Lewis structure. In such cases, such compounds exist as a hybrid or combination of two or more structures. Okay, hybrid or combination of two or more structures. This phenomenon is known as resonance. Let us take an example. In the case of ozone, O3, it contains two structures and these two structures are represented by a double-headed arrow. Okay. Here these two bonds, these two oxygen bonds are different. One is a double bond and one is a single bond, and this bond length is 121 pm and this bond length is 148 pm. Okay, but experiments proved that actually the oxygen bonds are equal and their bond length is intermediate between single and double bond. Okay, so the actual structure of ozone will be like this. Okay, this means that these oxygen bonds are intermediate between double bond and single bond, and the bond length is found to be 128 pm. This structure is called as resonance hybrid. And this is first structure, second structure. These two structures are also called as canonical structures or contributing structures or resonance structures. Okay. Also, these two structures have no real existence. Okay. Only the actual structure is resonance hybrid. Now, what is resonance? Resonance means when a molecule cannot be explained by a single structure, but its characteristic properties can be described by two or more different structures, and the actual structure is the resonance hybrid of these structures. Okay, so we can explain resonance. Resonance means when a molecule cannot be explained by a single structure, their characteristic properties can be described by two or more structures. Okay, two or more structures, and the actual structure is the intermediate between these two structures, is the intermediate between these structures. Okay, which is called as resonance hybrid, which is the resonance hybrid. Okay, so the different properties of this compound, this molecule, can be explained by the different structures, that is called as canonical structures, and the intermediate structure, which is the actual structure, is called as the resonance hybrid, which is the structure which determines the molecule. Okay. Another example is benzene. The two resonance structures of benzene are like this. Okay. And the actual structure is the resonance hybrid. Okay. In which all the CC bonds are intermediate between the double bond and single bond, which can be represented like this or like this. Okay, this means that all CC bonds are intermediate between C double bond C and C single bond C. Okay, so from this resonance, some important properties of resonance are: resonance stabilizes the molecule. Resonance stabilizes the molecule. So, as the resonance structures increases, means its stability also increases. Energy of resonance hybrid is less than the canonical structures. Energy of resonance hybrid is less than canonical structures. Okay. Then, next point, resonance averages the bond characteristics as a whole. Okay. Resonance averages the bond characteristics as a whole. Then, resonance energy is the difference between the resonance hybrid and more stable canonical structure. Okay, resonance energy is the difference between resonance hybrid and most stable canonical structure. Okay. These are the important points. So, as a whole, this resonance stabilizes the molecule. Okay.